So welcome back everyone to the another great day of a pure streak of day 179। और मैं ऑफिशियली यार अब बैंगलोर आ गया हूँ, तो अब कोई डेली वीडियोस आएंगी, कोई कंसिस्टेंसी ब्रेक नहीं होगा। एंड आई होप यू गाइज वर एबल टू मेंटेन योर स्ट्रीक एज वेल। एंड आई होप मेरे वीडियो का इंतजार रहा होगा आपको। तो ठीक है, शुरू करते हैं आज के क्वेश्चन को। टुडे इज इजी कैटेगरी क्वेश्चन एंड आई हैव स्किप्ड 2 days, दैट yesterday's हार्ड क्वेश्चन आई हैव सॉल्व्ड इट, बट आई विल अपलोड द वीडियो ASAP by today, or let's say by tomorrow. And there is one more question I have skipped in like 10 days before the last week, the hard question again, and I will solve that question as well. तो ठीक है, देखते हैं आज के क्वेश्चन को। I know it's been late, but yes, starting from tomorrow we will be on our time, so uploading the video between 12 a.m. to 3 a.m. I guess। ठीक है, शुरू करते हैं। तो it's an easy category question, and it says that there are n rooms in a straight line, and there's a Geekland State University's hostel. You have to bring a binary string S. So each Wi-Fi has range X. That's Wi-Fi in the ith room. Then its range go to X more rooms. You have to find whether the students in all rooms can use the Wi-Fi. Okay. So if any rooms does not receive an Wi-Fi, then you have to return 0. And if all the rooms are receiving, then only you have to return 1. So let me quickly show you the diagram of the input and output, and then we will proceed ahead. So let's say this have this string 1 0 0 1 0. So 1 implies that there is a Wi-Fi there, and X implies the range. So X is equals to 1. It implies, so there is a room. So it has the range of one room to its left and one room to its right as well. ठीक है, तो यहाँ पर अगर एक रूम और होता, राइट, तो क्योंकि इस रूम में वाईफाई लगा हुआ है, तो इसको भी मिल जाता वाईफाई और इसको भी मिल जाता वाईफाई। ठीक है, so when we are at this I equals to 0th index, so it can give Wi-Fi to this room, and there is no left rooms available. So this here, this one here has the Wi-Fi in its room, so it can give to this Wi-Fi. It can give Wi-Fi to the just left of the room and just right of the room, because x is equals to 1. अगर x equals to 2 दे रखा होता, let's say, right, तो ये जो 1 है, right, it can give Wi-Fi to the 2 rooms in the left and 2 rooms in the right. Right, ये इसको भी दे पाता और इसको भी दे पाता। I hope the question is clear. And you can clearly see that now each and every room has been receiving the Wi-Fi, so you have to return 1. That's the question. तो बहुत ही सिंपल है। Like सबसे नाइव अप्रोच क्या होगी कि I traverse in my string and I see while traversing whenever I found that the character is 1. If character is 1, right, then I will make 2 for loops. I will make one for loop to traverse in left, till which index, till x, right. Similarly, I will make one another for loop to traverse in right, till x more positions in right, until x more position in left. और मैं उनको क्या कर दूंगा, so I will make, let's say, one more visited boolean array of size n, right, and I will keep on marking it true, right. That would be the case. ठीक है, so it's a very easy naive approach, right. So try to code this solution, and before coding it, what would be the time complexity? This while loop or for loop for traversing each and every element will give you the time complexity of O of n, right? And then you are traversing the left and the right direction for each and every index. So worst case would be, let's say each and every room has the Wi-Fi. So if you are at this point, you will traverse till the x, let's say whatever has the range. So you will go x left and x right. When you are at this point, then you will go x, let's say x is equals to n as well, right. So you will move all the way to the right, all the way to the left. So it would be n cross x, right. The time complexity will be n cross x, and n is given, I think the constraint of n is 10 power 6, and x is also 10 power 6, right. So the overall time complexity in terms of numbers, it will be 10 power 12. So even if our logic and code is right, it should not get submitted. But one thing I have observed, that if you are able to code this solution, it gets submitted. So one of the possible reasons why it is getting submitted, because our logic still remains intact. If you are coding a solution which is beyond the 10 power 8, it should not get submitted and give you the TLE. But this is GFG, so sometimes uh, they forget to handle some test cases. You may have observed कि sometimes day में वो question में update होता है, there are some bugs there. So I think they do not have put any such cases which is going out of the bound of 10 power 8, and I think that's the reason this solution will get submitted. Please try this code by yourself, maybe take 2 or 3 minutes of your time, and then code this approach. Meanwhile, I will code the approach and then I will show you, right. So that's a very simple approach, so no live coding is required. Okay, so that's what I have done. Let me give you a very quick code walkthrough. So we are iterating for each and every characters in the string, and if the character is 1, We are marking it as true that this room will receive the Wi-Fi, as well as we are traversing in the right direction, right? Till how much points? Till x points. So if we are at I, then I will traverse till I plus x. Simultaneously, I have to check that I do not go out of bounds. So that is why there is AND condition, j less than and j plus plus. We are marking that the right rooms till x points from I as true. Similarly, we are marking the left rooms uh, with visited as true, and then at last we are checking that if any of the room is not receiving the Wi-Fi, that is if visited of I is false, then return the answer as false as return true, right? So let me hit the submit button for you. I have observed that this solution also gets submitted, although it should not be. So there's only one possibility, that there is no such test cases designed in a way that it is contradicting with our 10 per 8 logic. So okay, but still our motive of solving this question is not what to say achieved, because the expected is given you as O of n, and I can clearly see that we are doing a repetitive task, that for each and every I we are traversing till all the way to the left, all the way to the right, and clearly you can see there are sub problems, right? We are visiting a room more than once, right? So we can do this in O of n, that is we are visiting the room exactly once. How we can do that is that if I found a way, also please pause this video here again and try to think of it, that how you can achieve this solution by visiting the room just once, right? So how we can do that is that if we are able to found, right, for a current tower, so what are all the left towers, the left tower which can give it the signal, which left or towers, not, it's a room, right? So left rooms that can give him the signal, that can give it the signal, right? Similarly, if I able to found for the current tower or for the current room, what are all the left or what are all the right room where the Wi-Fi is present, that can give it the signal. अगर मैं ऐसा found कर लूँ, let's say if I'm able to do this, that currently let's say this is the room, right? And I know that which are all the rooms are present in the right which has the Wi-Fi, and I know which are all the room present in the left which has all the Wi-Fi. So if I know that room, then definitely I have the index. Let's say this is the index A and this is the current room and this is the index B. So if I can clearly do that A minus I will take the ABS values because we are talking in distance. If I say if it is less than equals to X, then means that A can give signal to I. And similarly, I can check that if B minus I is less than equals to X, obviously we will take the ABS because we are considering the distance. If that's the case, then I can clearly see that the Bth room where the Wi-Fi is present can also give the signal to I. So when can I say it is not reachable? I can say that if ABS of A minus I, right, is greater than X, that means A cannot give the signal, right? And I need to check that B also cannot give you the signal, because if any one Wi-Fi can give you the signal, then you are receiving the signal, right? So simultaneously I have to check that if ABS of this index B minus I should also be greater than X, right? Then I can say that this particular room which is at IS position is not reachable with any of the Wi-Fi present in the left or right, so it is not receiving any signal strength, right? How can we do that? How can we maintain a array, let's say, which informs us that what are all the left rooms for a particular tower that has the Wi-Fi available? So what I'm saying is that we have the string as this, so 10010, right? So let me make two array, that is A array and B array. So this is nothing but the handling the left, that is a signal receiving from left or tower itself. Why I'm saying tower? Because I think I'm working on a digital twin project which requires this tower thing. So that's why I guess I'm saying this tower. So from left or or the room itself or Wi-Fi, or the room which has the Wi-Fi from itself, right? And then again this will be the array which will determine that the current room will receive the signal from right room which has the Wi-Fi or the room itself. Or let's say, because for this the current room can also have the Wi-Fi, right? Or the room itself I'm writing. I hope you can get this. So even though when we do this diagram, then you'll be able to get this more clear, right? So I'm talking from the left. So what is here? In the left there is nothing room available with the Wi-Fi, right? So let us take a very huge variable, let's say not so huge, let's say 10 power 5. N was equals to 10 power 6, right? So let's say 10 power 5. So what I will do that, so the tower Wi-Fi is present here, right? So first of all, let us fill each and every entry with 10 power 5, 10 power 5, 10 power 5, and 10 power 5. Again, let us fill with the large values. I will tell you why this is happening. Why cannot we fill -1, right? Or -2 or -3? We will discuss that in the last. So I have filled with 10 power 5. So if I see that if the current index has the tower, right? So I will update with that index, and I'll keep on updating with that index itself until and unless I get a new tower, right? But for I equals to 3, I get an index 1. I get a room where the Wi-Fi is available. So I will update with the current index, and then I'll keep on updating it until and unless I found a room with a Wi-Fi. Similarly, here we traversed from right to left because we want to achieve that the rooms receiving signal from the left or not, right? If you see that, if I talk about this room, let's say this room, right? If I come at this room, then what this 0 is indicating is that this room has no Wi-Fi, but it can receive signal from a room present it left, which is at index 0, right? Forget about the x ranges here, right? So this left, for this current I equals to 2, it can receive signal from the left room which has the Wi-Fi that is present at index 0. We are just talking about the right indexes for A. Now we will talk about the B, right? So this is 0. So so for the left thing we have traversed from left to right. So that means for the vice versa, that is checking for the right, we have to traverse from right to left. Okay. So for this index, you can see that there is no Wi-Fi available. So we'll keep on going it. So it will be again 10 power 5, but you got a room with a Wi-Fi. So update with the current index, and the current index is 3. Keep on updating it. Keep on traversing until and unless you got a room with a Wi-Fi. So we didn't got, so update the same index. Now we got a room, so I'll update it to 1, right? So let me rephrase this array into a cleaner, board. So we have this 1 0 0 1 0. Let me use a different color so that it can be easily visually seen. So we have this A array as 0, and you know what this A array is depicting. So 0 0 0 3 3, and this B array is depicting nothing but 1 3 3 3 and 10 power 5. Right now I know. Right now is the what to say time to apply this logic. Right, this logic. Okay. So for, let's say, for I equals to 0, this is the indexes 0 1 2 3 4, right? So this 0 indicates the room position, right? So this is the room, right? And the Wi-Fi, the signal that can be reached from left is the index this, and the signal that can be reached to this particular room from right is this index, right? Similarly, if I come at this position, then it is saying that this room has no Wi-Fi, but it can reach, the signal can be reached to this room with the left Wi-Fi that is present at index 0, which is present here, right? And this current room can receive signal from the right hand side room itself that has the Wi-Fi, which is the nearest room is present at index 3, and you can verify that as well. So this is the pre-processing thing that you need to do, right? And we already discussed the intuition, that how we can do it. This logic, that's the only logic that you have to apply now, right? So what I will do, I will run a for loop for each and every tower. I will check it. So for I less than n, I plus plus, right? So what we checked for each and every tower, so for each and every I just need to check a minus I greater than equals to x and abs of b minus I greater than equals to x, right? So this a is nothing but the left index, my current index, right? So I can clearly check that abs of a of I minus this a was nothing but the index of my room, right? So I can, so the left room is present at a of I, my current room is present at I. If it is greater than x, and abs of what, b of I, the room in the right which has the Wi-Fi, minus I is greater than x, then that is not reachable, right? I've explained this logic multiple times. Okay, so if that's the case, If that's the case, that means that this room present at the eye is not receiving any signal. And if that's the case, then the question is saying me to return false. So I will say return false. And after the for loop, if everything seems good, that no index catches this case, this if case, then we need to return true, right? Okay. So this will be the last step. This will be the last step, and this will be a first step of doing the pre-processing, right? So please pause this video and try to code this yourself. I have explained you many things now, the entire thing, not many things. Now you just have to pause this video for maybe 2 to 3 minutes and try to code it yourself. Meanwhile, I'll also show the code and code it myself. Okay, so that's the code. Let me give you a code walkthrough. So we have made an int a, int b to store the left and the right available nearest room which has the Wi-Fi. We are filling with a large value 10 power 9. Okay, so why are we filling with 10 power 9? Because you can either fill with 10 power 9 or 10 power 5 will also work. Let me change it to 10 power 5. Or you can change yourself and verify. Let me just give you the reason. So n is 10 power 6, right? So the nearest room, let's say, if we have a 10 power 6 array and at the first index we have a room 1 and each and every case is having 0, right? So that is why we are using a big number to fill it, because then the subtraction, because we are always finding the difference, right? So it should not exceeding our x, that is also equal to 10 power 6. So that's the reason we are handling it. If you take it -1, it will not work, right? -1 or -2, it will not work. You can verify with a very simple test case. Take 4 zeros, 1101, and then you can verify it yourself, right? Okay. Or you will definitely get a wrong answer for this particular test case I have showed you. Four zeros, 11 and 01. Try it yourself if you are curious to know. Okay. So that's the for loop to fill the left nearest room with the Wi-Fi, and that's the for loop for line of 49 to fill the nearest room in the right with the Wi-Fi. And at last we are checking if any room is not reachable, right? I've explained you this logic. And at last we will be returning true. If not, if the thing are cached, if any cases are cached in this line of 57, then it will return false and it will return true. Okay. So let me omit this extra brackets. Let us compile and run. And while it is compiling and running, what would be the time complexity? You can clearly see that we are using a 3 parallel for loop still. I goes to 0 to n, or in the reversal. So it would be O of n, and the space complexity will be again O of n, right? We are using a 10 power 9 array. Okay. So we have optimized the solution from n cross x to n, and it will definitely now get submitted. There is no is and but in this solution. Let us wait for some time and we'll verify as well. So that's it. We have solved this question using the two approaches. The one approach was using n cross x, and now it has been done in O of n. So I hope you guys were able to understand the solution, the intuition, the logic building behind it. So great. We will meet again in the tomorrow's POTD streak for sure. Until then, keep learning, keep growing. Bye bye, and take care. Use the comment section constructively. I am saying that I will upload my all the 2 pending videos for sure. Maybe it will help for you guys as well, and I don't even want to skip any question for my growth as well. So let us meet tomorrow. Till then, keep learning, keep growing. Bye bye, and take care.